Alright folks, in the last chapter we spent some time looking at how a chemical equation can be used to predict the number of moles or the number of molecules in a chemical reaction that you might produce. So if we just do a little flashback here, this is throwback. It's not Thursday though, but anyway, we have 2H2O, and that gave us 2H2 plus O2. And we know that if we have, say, this is our ratio. These numbers underneath here are our ratio. So we have a 2-1-1 ratio, which means that for every 2 moles of H2O I have, I get 2 moles of H2, and I also get 1 mole of oxygen. So let's just say, for instance, I have 10.3 moles of H2O, and I want to know how much O2 that will give me. Okay? Well, this is a very simple problem. That's what we did on the last video. We take 10.3 moles of H2O, and I look at my ratio. What's my balanced equation here on H2O? It's 2. So I got to cancel this out here, so I got to put it down. 2 moles of H2O. Notice my labels right here are going to cancel. And what does that equal? 2 moles of H2O is going to equal 1 mole of O2, which I'm trying to get to. Okay, I'm finishing with the label that I want, which means that 10.3 divided by 2 equals my moles of O2. Okay, so I think a fairly straightforward problem. It's a one-stepper railroad track, something that shouldn't be too difficult for us to work on. Okay, we're going to move on now. This is chapter 9.2. We're going to start with that same idea. The book calls this chapter Using Chemical Equations to Calculate Mass. I prefer a way cooler name, I think, and we're going to call it stoichiometry. So this is chapter 9.2, stoichiometry. And we're going to take the same idea, but we're going to add one step to it, something that we can actually count. It's hard for us to count moles unless we have a scale. So we're going to use this idea of counting by weighing, which we did a lot of in the previous chapter. We're going to count by weighing, and we're going to be able to determine how much grams of something we might be able to produce. Okay? So I'm going to take this same example that I did before, and it's just this. 2H2O yields 2H2 plus O2. Okay? And it's pretty balanced. I have my ratios. As you can see, little technical difficulties there, but I have my ratios, as you can see right here, where I have a 2-1-1 ratio. Now, previously I had always been giving you the idea of moles, but let's just say I have something I can count, because I can weigh water pretty easily. And let's say I have 44 grams of H2O. That's fairly straightforward. And I want to know how many grams of oxygen I produce. Not how many moles, but how many grams. Okay? So we've added essentially 2 steps into this problem. Okay? This is not terribly difficult. You just have to be very, very careful. Remember to cross your labels down and try to keep your railroad tracks neat, and it should be okay. All right, so let's just start with what we know, like we always do with our railroad track problems, okay? I can't convert grams straight to grams, but if I go from grams to moles to grams, I'll be okay. So I'm going to start with what I know. I know I have 44 grams of H2O. I also, my first step, my number 1 step, has to be start with what I know. Okay, so that's number 1. Okay, number 2 step, I have to convert this to moles. I can't work with grams. I can count grams, but I can't do math with grams. So I need to convert this to moles. Remember that if you look up the molar mass of H2O, you'll find that H equals 1.01, that's going to be times 2, and O equals 16 times 1, so that will give us 18.01. So that's how we get that. We're going to say 18.01 grams of H2O is going to equal 1 mole of H2O. Now, look at my labels. I got grams of H2O here and grams of H2O here. These cancel out like I want them to cancel out. Remember, my final label should be this grams of O2. That's what I'm shooting for. So I have to keep working until I get to grams to O2. Okay, now now that I've converted this to moles, I've converted my grams of H2O to moles. My third step has to be to apply the mole to mole ratio. So I'm going to say apply mole ratio. And my mole ratio is going to be my 2 here that I have to my 1 here, because that's the case of the oxygen. Really, all you're doing is looking at the equation. Okay, how many moles of H2O do I have in the equation? Well, I have 2. Look at, I already have a mole label there, so I need to put my moles of H2O down here. And what am I trying to get to? Well, I'm trying to get to oxygen, so I need to compare that to my moles of oxygen. So moles of oxygen. Okay, again, looking at my labels here, I got moles of H2O, moles of H2O. These are going to cancel out, cancel each other out. Now I'm at moles of oxygen. I'm actually doing pretty good. I'm almost done with the equation, right? All right, so once I apply the mole to mole ratio, I convert. There should be an N in there. Let's just try that again there, Mr. Strasser. Oops. Man, tough day for the old surface pen. Okay, here we go. We're going to convert mole to grams, because grams is something I can count again. I want to know how many grams of this I'm going to get. Well, what do I have up here? 1 mole of O2. I can hopefully convert 1 mole of O2 to what it would be in grams. So keep in mind, though, this is O2. Okay, O2 would be 2 oxygen molecules, so it would be 16 times 2, which would mean O2 has a molar mass of 32.0. Okay, so here we go. I got to put my label of moles on the bottom. I know that 1 mole of O2 equals 32 grams of O2. Keep in mind, every single, well, let's look at our labels first, I guess. Moles here, right? Yeah, moles of O2, so those cancel out. What am I left with? Grams of O2. Is that what I want? Yay! It is. Okay, because I got the label, so I'm there where I need to be. Keep in mind, each of these statements that I've made here are true statements. They have to be true. If they're not true, then the problem doesn't work. Okay? Here's a great way to just look at it. Okay? These are your rules. These are your steps. If you can figure that out, these problems should not be too difficult for you. Okay? Once we get here, I've said it time and time again, don't let your calculator defeat you. Don't let your calculator defeat you on this. It's 44, everything on the top times everything on the bottom, divided by each other. 44 times 32, divided by 18.01 times 2. Okay? You can do that math on your own. Okay, so these problems I don't think are too terribly difficult. We're just using these masses to kind of calculate what we have and where we're trying to get to. So let's do another one here. We could kind of switch it up here a little bit. We're going to give this equation right here. I guess maybe it might have been a good idea to say that the first step is to make sure the equation is balanced. A lot of times the equation will be pre-balanced for you, but not necessarily all the time. So if it doesn't have any numbers on it, do not assume that it's balanced. Okay, this is a goofy kind of guy. This is a reaction with aluminum and iodine. Remember, iodine's a diatomic element. That's why I went with the I2. And it's going to produce this compound called aluminum iodide. This is not balanced. I need a 2 here and a 3 here in order to make this balanced. Okay? We're going to use the same idea, the stoichiometry, to calculate how much we can produce or maybe how much we need. Let's say, for instance, iodine's kind of an expensive element to use, so I want to know exactly how much I need for this reaction. So say I have 35 grams of aluminum. I want to know how much I2 do I need to react with it? Because I have 35 grams of this, and I want to know how much I2, this iodine, how much do I need to react with all of the aluminum and use it all the way up? Okay, so these equations don't necessarily have to show you how to produce something. They can also show you what you need to produce it. Okay, so we're going to start to work this problem here. Again, let's write down our steps. We're going to convert to moles. Next step is mole to mole ratio. third step. Am I skipping a step here? Convert to moles. No, start with what you know. I put that first. Okay, same deal. Starting with what you know, mole to mole ratio, and then convert back to moles. Okay, I left out like 1A, I guess, which we'll call start with what you know. Okay, not sure where I was there, but we're just going to pick this up. We're going to, yeah, that was 1A. Start with what you know. I had a little interruption, sorry. Okay, so here we go. We're going to do this problem. We want to know how much, and that means grams, by the way, of I2 do we need to finish the reaction. Okay, starting with what I know, 35 grams of aluminum. Okay, what's the molar mass of aluminum? Let's look that up here. 26.98. So from your periodic table, it says that 26.98 grams of aluminum is the same as 1 mole of aluminum. So there we go. Starting with what I know, I converted to the mole ratio. Okay? Looking at my labels, I got grams, and grams are going to cancel out. Right now I'm at moles of aluminum, so I need to switch this moles of aluminum to mole ratio to what I want to get. I want to get to iodine. Well, I got aluminum on the bottom, so I know that I have a 2 up here. That means the 2 goes down here. Moles of aluminum. How many moles of aluminum equal the same amount of moles of iodine? Well, in this equation, it's 3. Okay. Looking at my labels, moles of aluminum, cancel out with moles of aluminum. I'm at 3 moles of iodine. Okay. Last part here, then, is just convert back to mole. So 3 moles of, I got to put moles of iodine here at the bottom. And how much does a mole of iodine weigh? This is going to be a nasty one. 126.9 times 2, because I have 2 of those atoms in one molecule. And that'll give us 253.8 grams of iodine. Okay? Cancel that out, by the way. And convert back to, does that say convert back to moles? How foolish of me. Convert back to grams. Okay? Did I convert it back to grams? Does this label match up with what I want here? Yes, it does. It says 35 times 3 times 253.8 divided by 26.98 times 2 equals what I'm going for. Okay? Equals grams of iodine. I'm not going to write that out, but hopefully we get the idea here. I can do this with just about anything. There's a little more detail we can get into these problems. I'm not going to get into them right now. This video is already 13 minutes long, so that's the end of the video. We'll do a couple of these practice problems in class just to see how we're kind of doing on it, but hopefully you have some notes down for it, and we'll work on an assignment 2 in class. Alrighty, that's it for today.